Okay, so now check out part 4. The major product of this reaction exists as two stereoisomers. Draw both isomers, show all hydrogen atoms in the structures, and use wedge and dash bonds to indicate stereochemistry. Okay, so I'll try to write out the mechanism for this reaction. So we have like an ethyl group popping out at the top. It's connected to a double bonded carbon with an H, another methyl group, and yet another methyl group. So it reacts with Br2 and then a large excess of water. I'm just going to write a note up here that when this reaction occurs in water, this results in formation of a bromohydrin. So I'll show the mechanism and kind of explain what that even means. Basically, I'll have the Br2 right there. And then the first step is that the double bond comes in, grabs one of the bromines, kicking off the other one. And then we're left with the following intermediate. Okay, so basically we have the bromine kind of reacting like that. I'm gonna move this over a bit. Okay, so now this is what the bromohydrin is. It shows that the bromine is kind of blocking this whole side of the carbene. So since bromine is kind of blocking that side, when you have a water molecule come in, it's going to attack from the opposite end. So basically its mechanism looks like this. It's going to attack carbon over here on the opposite side, and then the bromine is then neutralized, and then the next product looks like this. So now we have our water molecule attached, and the oxygen from that water now has a positive charge. So essentially another water molecule comes in and deprotonates that group to relieve oxygen of that positive charge. So this is going to come in, take one of the hydrogens, and basically we're left with an alcohol group. So I'm going to show the stereochemistry in one of these products up here. So essentially we have a new bromine added, and we also have a new alcohol group added as well. Okay, so this is one of our products showing the stereochemistry. Or we could have the following. And then I'll kind of just explain why this happens, like over here. So basically, the bromine was added to the less substituted carbon. And also bromine and the OH group are at opposite sides of the plane. This is called transaddition. Okay, so let's look at the answer from our junior tutor. And you can also see that the question kind of gives a hint when they got it wrong. It says the stereochemistry is incorrect. After the formation of a bromium ion intermediate, water attacks it from the side opposite the carbon-bromine bonds. So this person put alcohol and the bromine kind of looks like they're on the same side. Let's see what our junior tutor said. They have the bond attacking the bromine, water coming in, and they simplified it a bit, but basically it showed that the structure is correct, like the compound, but I'm just also gonna add structure is correct, and also draw Br and OH at opposite sides of the plane. And then in brackets, transaddition. So just a little note. So that solution